This video is the solution to example 9 to example 12 on the topic of statically determinate frames. In this video, now we have a simply supported frame instead of a cantilever frame. So in these type of problems, it might not be straightforward to draw the deflection straight away. So it's always a good idea to start with the reactions. So for example, if we look here at the support on the left, we can see that this reaction has to be 0 because it's the only horizontal one. But then the vertical reactions, we need to calculate them. In this case, if you solve for the sum of moments, for example, here at point A, you can get the reaction here is going to be 50% of the reaction on the left side. So the total here is 12 times 6, which is 72. So you get that the reactions are 36 and 36. So with this in mind, you can go to the Bendy moment diagram and conclude that the way this is going to look is we have a roller support, we have a pin support. The moments have to be 0 there, they have to be 0 here. So what we know is the shear force at AB, so in the column, is 0. So the moments has to be 0 because the slope is 0, the initial value is 0, so we can't have any moment. So now we get to a position that this is a moment that we know straight away. The quadratic moment starts from 0, finishes at 0, and the value here is WL squared over 8. So in this particular case, that's 12 times 6 squared divided by 8, which is equal to 54. Okay, and now we get to a position to draw the deflected shape. And in this case, what we know is the beam has tension on the bottom, so it's going to be a happy beam. But then the bar on the left side, so the column, cannot bend. So if you try, for example, to draw it like this, and then like this, we have a little problem that we're breaking a rule here in this angle, that this angle needs to stay 90 degrees. So what's going to happen is our beam, to stay happy and for that angle to stay 90 degrees, this needs to move a little bit to the left. So now you get your 90-degree angle getting off in here. Okay, not very good drawing, but let's say it is. And here, your point can move to the left because this is a roller support that allows for this to move to the right, not to the left. Okay, so this is the way the deflected shape works. Again, this point here doesn't bend. This bar has no bending. Okay, we can go now to the next problem. By the way, in terms of shear force, the shear force will be 36 here, then down, then up. Okay, and then 0 on the column. Now, moving on to the second one. In this particular case, it's still easy to calculate the reaction. So in this case, it's 30 and 30. So the deflection is going to be very similar. And the bending moment is also going to be very similar. But now, the only little difference is instead of having a parabolic moment in the beam, we're going to have still 0 in the column, but here we have a triangle. And the value here is going to be 30 times 3, which is equal to 90, or the formula usually is FL over 4. So if you try 60 times 6 divided by 4, you should get your 90. Now, in terms of the deflection, I'm not going to draw it again, but the deflection in this case would be exactly the same as this one. Okay? Obviously not exactly the same, but the sketch will be the same. Okay, let's move on into the next one. So now it's the same case as before, but now we have a load of 30 also pushing the bar to the right, so the structure to the right. Now the reactions, the horizontal will be 30 here. And now if we want to do the reactions, let's say here at point C, we can do the sum of moments at A to figure this out. So if this is point C and we're trying to find that reaction, we have 60 times 3 is 180 plus 30 times 4, that's 120, so that's 300. And if we do 300 divided by 6, we can get this reaction here. And 300 divided by 6 is 50. So that means this other reaction is going to be 10. So that's the way the reactions look in this case. So now we can go into the bending moment diagram and try to use all this information to get our diagram straight away. So we do have a load of 30 trying to push this point to the left, right? This point here, trying to push it to the left. So the bar will bend in this direction. So we will get tension on the inside. So the moment here is 0, and now we know we're going to have tension on the inside. Another thing we know is this tension on the inside probably is going to stay constant since we don't have any load. So we can get that the moment here is just going to be 30 times 4, and that's 120. Okay, the same way when we had moments outside, they transfer outside. For example, no, we don't have an example here in the examples in the previous videos. This moment now transfers inside. So the moment of 120 is this initial moment in the beam over there. So this transfers inside, moment of 120, and that's our starting point. And now we can think about this load of 10, then we have a load of 60, and then we have a load of 50. So to make sure we don't make any mistake, let's stop doing the bending moment diagram and start doing the shear force diagram. So then we can use it to make sure our bending moment diagram is correct. So in terms of shear force, we do have 30 and 30 that do this on this column, but that we knew already. That's the slope of this line here. Slope is 30. But now in the beam, we have 10 on the left, then the 60 pushes it down, and then we have 50 on the right. So the shear force here is going to be 10 here, and then when we get to the 60, this pushes it down to minus 50, and then it closes there. So 50 and then 10. So now we can get the moment. Finally, this is going to be 10 times 3, so that's 30, the area. And then this area here will be 150. So now we're in the position to take this 120 and know that here in the middle, the moment will be 150, that's 120 plus 30, and then the 150 minus 150 will close it to 0. Okay, so now we're in the position with the bending moment diagram to draw our deflected shape. And in this case, we do have tension on the right in the column, but it's very important as well that you understand this is a pin support. So now the only constraint that we have in our deflection is that this point needs to stay here, but the rotation can be whatever we want. Okay? We don't need to stay flat in that particular point. So now if we know this needs to be here, and then we're going to have tension on the right side, this deflection is going to look more or less like this. Okay? Now, if we want to keep our 90-degree angle, and we want this to be happy, this means this deflection, I curved it a bit too much, so it should be more or less like that. And then here, we keep, and again, I bended it a little bit too much again. Let's try to bend it a little bit less, like this. And now the 90-degree angle will make it do this. So we have a happy beam, and then a column with tension on the right, and this point here can move to the left and to the right, so this is fine. The only thing it can't do is to move up and down. So this is the deflected shape of this problem, which I guess kind of makes a little bit of sense, that it's similar to the previous one, but now the difference is that this bar here is bending, while in the previous case, because we didn't have this horizontal load of 30, that bar wasn't bending. Okay, that looks good. Now let's get to this final exercise. So now we have load of 30, so now we're going to put 30 in this case. That's where we have the horizontal reaction. And now let's do the moment here, for example, to calculate this force here. So we have 60 times 3, 180, and that's counterclockwise, right? We have 180 like this. Then we have 30 times 4, so we have 120 in that direction. So that means 60 is going to win, right? This 60 is going to win. So our reaction has to compensate that 60 by being equal to 60 divided by 6. So if we put this equal to 10, then this reaction here will give me the 60 I need to compensate all of this, okay? So I'm basically doing the sum of moments in this point here, let's call it D, sum of moments at D, but instead of writing it down, I'm just thinking about what are the effect of each load separately. So now if I know that load is 10, then I know this load here is 50. So my next step should be to draw the bending moment diagram again. I could try to draw the deflection straight away. If you're comfortable with that, you can start with the deflection. In this case, I think I'm not necessarily ready to try the deflection straight away, but I can do it once I do the bending moment diagram. So the first thing I know is that moment here is 0, moment here is 0, but then in this column here, so let's call it column AB, I know shear force has to be 0 as well, so the entire column will not bend. So then I know this moment here is 0, then I'm going to do the areas of the shear force in a little bit, and also I know that bar DC, so the other column on the right, will bend towards the right, so we'll have tension on the right, because this force of 30 will cause a moment on the right side. So what I know straight away is that this needs to go there, and my moment there will be 30 times 4, 120. And then here, this will transfer outside, 120. Okay, so I'm happy with that. Let's just do the shear force diagram to understand how that bending moment is going to play out there. Let's see. So shear force diagram, we know it's 0 in the column, and then it's going to be 30 in this column here. And then finally, in the beam, we have 10 and then 60 that pushes it down. So this value here is also 10. Then the 60 is going to push it to minus 50. And that's the values of the shear force. So again, same areas as before. This area here is 30. This area here is 150, and it's negative. So that has all the information I need to then know the moment here is going to be equal to 30, and then minus 150 gives me the 120 that I need to close all of this. Okay, I'm happy with this. Final step, deflected shape. And you'll see it's a lot easier to draw the deflected shape if you have the bending moment diagram, because now you know what needs to bend in which direction. So we know first, this bar here will not bend, and then we know the second column will bend towards the right. So this is the same example as before. Let's try to bend it like that. And again, let's try to make this angle a little bit inclined. So then with the 90 degrees, this will start bending upwards. So that means it will bend with tension on the top, it will bend downwards, but the initial slope here will move it up. So then this will get 3 meters of happy beam, right? That's this amount here is happy. It's not 3 meters, it's a little bit less than 3 meters. But then very quickly gets back to unhappy, and this should be more or less the deflected shape. Once we get to this stage, we need our 90-degree angle, so this just stays flat. We know that's not going to bend. And this point is going to be able to move a little bit to that side. So I would say that's a reasonable deflected shape for this case. So I'm happy with this. I have tension on the top here, I have tension on the right here, and I have tension on the bottom here, which matches with what my bending moment diagram is saying. And again, no bending in this case. Okay, so thank you for watching. I hope these problems are getting easier with videos, and hope you can find more examples to practice, because these things, they take a little bit of time, but once you stop being afraid of all these different methods and you start understanding them as an advantage, you can start solving these problems more easily. So thank you for watching, and have a nice day.